I equals MEF. So we just have PEG equals PES. So this is MGH equals 1/2 K x squared. So x is the square root of m over k, GH. What's that? Oh, because the kinetic energy is a transitive form of energy. I know it's going to become kinetic, but because there's no friction, I know that all the potential becomes completely kinetic, which then becomes completely potential energy of the spring. Does that make sense to you? Because, like, what is the spring going to do when this is at maximum compression? What's that? Yeah, before it launches, what's it going to do? What's this block going to do at the bottom? Stop. And you know that when it stops, that's no kinetic energy. So you know all the PE had to become KE. Does that make sense? Right, so like, this is all PEG up here, totally. But down here, when V is 0, that is all PES. You see what I'm saying there? It's like when I toss this up and it comes back down, right? Like right as it leaves my hand, it's KE. And then that KE reduces as PE increases, and so up here, it's all PE, right? And then as it falls, so if it falls, if I take a spring and I pull it down to its maximum compression, and then go boing and shoot it up, it's going to go up to a point, and where did all the energy start from? Yeah, from the spring, right? PES. And then boing, it became this up here. So do you see how the opposite is true? Yeah. So then that X max is at 2 mgh over K. Now this V max, or this X of V max, where does this occur? When what is true? When does this X, like, when is this box moving the fastest that it will move in this system?
Just when it leaves.
Yeah, we know that it's going to be maxed when the things that accelerate it are not accelerated. Right? Because if those two things, think about this, let me pause this. I don't know if you want to, well, actually, I'll leave it. Think about this in terms of antagonistic stuff, right? Like if I'm trying to push this way and something's pushing me this way, right? So let's, I don't know, I'm running into a wind or something that's blowing this way, or I'm going to run into a spring. When I run this way, I have some acceleration, or all right, we'll just use this thing. What's the acceleration down the incline? No, just g sine theta, right? Because you know the acceleration is the part of it that's going down. So the acceleration is g sine theta, and that's the whole way down, right? Does the total acceleration change at any point? Yes.
Oh, when it hits the spring?
Yes. The moment it hits the spring, now here we go. Which direction is the net acceleration the moment after it hits the spring? Sure. Which direction is the net acceleration the millisecond after it hits the spring?
It depends how.
Did you hear what Anna said? Okay, we're assuming that the spring can't exert its full force in 1 millisecond. But yeah, there you go. The acceleration is still down, which means it's still going faster. It's just going faster less quickly. Right? Like, as I'm going down, maybe let's say sine 30 or something like that. So I'm increasing my speed at 5 meters per second squared. Does that make sense as I'm sliding down the incline? Once I hit the spring, in my next step, I drop down to 4 meters per second squared, but I'm still accelerating. Now I drop down to 3 meters per second squared, but I'm still accelerating. Right? Because before, just as I hit, let's say I was going 10 meters per second, right? Then in the next second, now I'm only going, instead of what I would have normally gained another 5 meters per second in the next second, now I only gain 4. And then in the next second, instead of being 20 meters per second, I only gain 3. You get what I'm saying? So it's my acceleration is decreasing, but it is still positive. So we're still accelerating down, and this is that whole discussion we had on remember that big discussion? And it was really good because that sets us up for this, right? So equilibrium is the point at which, right, the force of gravity, that acceleration of gravity is going to get matched by the force of the acceleration of the spring. And after that point, now the spring overcomes gravity. And now I accelerate back up the incline, which means I start slowing down. So this occurs where the sum of the forces in the quote-unquote x is equal to 0. Yes. Well, no, it's when it momentarily stops accelerating, and then it goes from a acceleration down the hill to an acceleration up the hill. So if I do my force diagram, right, then we see that this is mg sine theta, and we know that this is going to be Fs. So when it hits this, the sum of the forces in that direction is going to be, I don't know what's positive, whatever, we've been saying down the hill. So let's say mg sine theta minus Fs is equal to 0. So mg sine theta is equal to kx. So x is equal to mg sine theta over k. Oh, that's crazy.